To begin the second iteration, in the objects context, grab and drag out a copy of the first iteration. Rename it second iteration. And then dive in. For housekeeping, I'm going to take the previous solutions, the network boxes in green, and recolor them into gray to show me that these are old solutions from the previous iteration. New network boxes will receive another color to show me that these were generated in this new iteration. Continuing from the end of step 1 using the switch node, I'm going to drag out a wire and place a blast node. The group I want to work with is front scalp, as I want to attempt to design bangs with a new solution. To find the size of this region, I first must place a bound node. I'm going to increase the upper and lower padding by a slight amount. This value can be changed at a later time as well. A line is going to be used in the X direction to then be match sized to the bound box. Next, check the scale to fit option. After match size, I'm going to connect a resample node. The purpose of this node is to be able to add more points within the line so that when I use a copy to points, I can have any number of objects copied to this line. For now, I'm going to uncheck the max segment length and check the max segments and leave it at 10. To remind myself that this node will control things later down, I'm going to give it a different color. The object that I have in mind to copy to this line will be a grid. The purpose of the grid will be to create slices along the scalp, working from front to back. The orientation of the grid should be the YZ plane for this purpose. Connecting the grid into the first input of the copy to points and the resample into the second input, I could set the view flag and see what I have so far. I could resize the grid down to a 1x1 size instead of the default 10x10. This stack of grids is perfect for making slices. Now all I need is the Boolean node. To remind myself the purpose of this resample node, I'm going to change its name to slice count. In order for the slicing to work, I want to change the set A and set B treat as to surface. And then I'm going to use the operation seam, wiring the blast front scalp into the first input of the Boolean and the copy to points array of grids into the second input of the Boolean will give me the results that I want. These columns of lines can then be resampled with a resample node, in which I uncheck the max segment length and check the segment. Again, I should recolor this node red to remind myself that it can be reused later. Additionally, I'm going to rename it to column resolution to remind myself of its purpose. This is a solution for placing down future curves, so I'm going to give it a network box, calling it Step 4 Guide Columns. The curves that I want to place along these guide columns can be a Bezier curve. If you work better with NURBS or Polygon, you can use that as well. I like the control that the Bezier curve has with the handles in the viewport. At this point, I'll also rename this node to front left. I need to template the head in order to be able to see where I'm drawing my curve. In the viewport, pressing space 2, I can move to the front. Templating the blast of the front scalp helps as well. And as long as the Bezier node is selected, I can then move to the viewport, hit enter to enter into the active state. And then with the letter G, I can begin drawing out points. Command 2 offers me a second screen to work with, which I can set to the side profile with space 4. After I have the curve that I can use to make the corner hairs of the Groom, I can switch the mode by pressing F to edit my points. All you need to do is drag out a box around the point of the curve, and then with the middle mouse you can move the entire point or curve, if you have all points selected, to anywhere that you'd like. Additionally, you can control the handles by dragging the handle, which is the green line extending out from the points. Or you can just grab the arc itself that's created and pull up and pull down to bend the arc accordingly. The front left curve is already a good start, so I'm going to drag out a copy and rename it to back left to use later. When working with curves, make sure that the first point clicked, which is point 0, will be at the root of where I think I want my hair to be. And then the tip will be point 1. The Bezier should be converted to a polygon. Using the convert node at the default settings, I can accomplish this. And now with the resample node, I can get control over the smoothness of this curve that has been created from the Bezier upstream. The goal is to be able to create a curve that could become a primitive, like a polyline, and then place it at the origin so that if this was to be copied to points later along my scalp columns, that it would go to the exact point instead of being off in space, as it is very far from the origin when it was first drawn. But I still like the control of being able to draw where I see the scalp so I can have a more hands-on approach to understanding what the Groom shape should look like. Now, using a blast node and setting the blast to points, I can pick group 0 to just isolate the root. With a match size, I can bring this point back to the origin. And then clicking Stash Transform to get the Xform attribute, I can have this saved to use a attribute copy and copy this transform back to all the points. In the attribute name, I'm going to select Xform. And now using a transform by attribute with Xform already entered, the curve now moves itself to the origin. For my own personal assurance, I'm going to add on a sort node, setting the point sort by vertex order. This is just so I'm absolutely sure that the Bezier originally worked all the way down and has the points counting in the proper order from root to the tip, ascending. This is a new solution. I'm now wanting to create a network box around it and call it Step 5 Curve Placement. Now I can draw any curve I want in the Bezier node above, and then have it proceed through this node tree and come out snap to the origin for use in copy to points later. Now I'm going to work with the back left, and with the back left and the front left, I can now connect both the chains into a wire blend. Dragging the slider in the wire blend shows the gradual transformation of input 1 into input 2. This is bringing the desired effect. And now I want to get this slow blending to happen along the column that's been created along the scalp. Using a blast node and choosing primitives, I can take any one of the columns that was made from the Boolean, which created all the seams. I'm going to start with the first primitive. Going back into perspective mode and reducing down to one camera view, I am taking a look at which primitive I've blasted, and blasting 0 works just fine. Dragging up and down with the increment ladder shows the other primitives that were available. Now I want to copy to points this blended wire to the points available on that column. Connecting the wire blend into the first input and the blast into the second input, I can now see the wire blend being pasted over and over to the points, but it looks exactly the same. In order to get a slow interpolation from one input to the next, I need to do a for each point loop. With the wire blend out going into the first input of the copy to points and the blast out going into the for each begin, I can now create a metadata node in which I can read off the detail attributes of iteration. Coding in the iteration into the wire blend will help with the for each loop. To do this, I type out detail, open parenthesis, quote, double dot to jump up a level, /, and then I want to get the name of that node that has the iterations, which is node number 60 on my screen. End quote, comma, quote again, and then take the iteration, close it with quote, comma, 0, close parenthesis. And now I can see that it has pasted those individual curves working from front to back. However, they are blending beyond 1. In order to get them to blend from 0 to 1, I simply need to divide this original code by a channel referring to the column resolution and then end it with /segs for the amount of segments in that column. There we have it. Individual curves placed along each point of that column, slowly blending from the first input to the last input. Inside the for each end, if I click single pass, I can drag along a slider to see all the different points that were copied one at a time. And in the wire blend, depending on which pass I want to look at, I can see what percentage I've moved along from 0 to 1. Now, turning off single pass, I want to do this again, but this time for the right side. I will have to create the curve placement solution again, which I can just drag out a copy, but I want to also have different curves designed for the right side of the scalp. At this point, it also makes sense to rename the curves so that I know which one was the front right and which is the back right, in case I want to change these at a later time. I could see that the wire blend is still referencing the correct new for each loop metadata. And now it's time to template either the head or the blasted scalp so that I can see where these curves are going to be placed and what they should look like. Additionally, I can choose a different primitive to blast to try this right side of the head out. Since this is a new solution, this copy to points inside of the for each loop, I'm going to give it a step 6 network box called curve interpolation. This time I'm going to work with primitive 8 on the right side. Returning to the screen format, for the first time, the left curves are drawn of having two screens, both orthogonally viewed, right and front. I'm now going to begin working with the Beziers on the right side. I need to first select the node and then press enter in the viewport to enter the active view state. And then I can take those copies of those first Bezier curves and adjust accordingly by hitting F in the viewport to work with the modify settings, and then just selecting the points and middle mouse dragging to place them in new locations. Checking the last node in the for each loop, I could see that the interpolation is working just fine. Now, the challenge is to get the left side to slowly interpolate to the right side. To do this, I'm going to bypass the blast nodes by adding a junction into the wire. And similarly to before, I need a for each loop. This time it's going to be for each primitive. The for each begin output should now go into the input of each for each point begin, similarly to the way the blast nodes were entering at that point. Now is a good time to create a metadata import node to collect iterations. Lastly, the output of the for each point loops should now be fed into a wire blend. Similarly to before, I need to enter in the code to pull upon the detail attribute of the metadata for this larger for each primitive loop. Hitting Command B, I'm going to take the network and make it full screen. And then I'm going to drag out the parameters window just a little bit wider to be able to see the code that I'm about to enter. Again, that code is a detail attribute. So detail, open parenthesis, quote, and then double line to jump up a level for the node, /, and I can see the available nodes around, which should be the 64th node, my metadata node for this for each primitive. End quote, comma, open quote, iteration, end quote, comma, 0 to reference itself, close parentheses, and then divide by a segments. Instead of the column resolution segments, I'm going to divide by the resample node, which is the slice count. That will be channel, open parenthesis, quote, double dot, /. Now I need to find that node number 42. / and take segs, end quote, close parenthesis, and now I have a blend that should blend from 0 to 1. And it's working. At any time, I can go back to one of my Bezier curves and adjust. And I can see all of the other curves using that wire blend. They're interpolating in between the other 4 curves that have been assigned into this for each solution. This gives me full artistic control for the input guides that I want to create from these curves. I no longer need the blast nodes, as they were just for experimenting with the first for each loop. Dragging up on my slice count in the segments, I can see more segments means more columns created. And changing the padding of the bound can increase the width of where these columns will land on that scalp. These curves on their own look useful, but they do not work with guides until they have the skin prim and the skin prim UV attribute assigned to them. To get this, I need to add the guide skin attribute lookup. I'm plugging the for each loop curves into the first input and the scalp into the second input. I can get this attribute assigned, and these lines that were created as Beziers transformed into polygons can now be used as input guides to grow hairs in a hair generation node. Connecting the guide skin attribute lookup into the second input of hair gen guides and the scalp into the first input can now see what hair generation would look like if it was to follow those guides as reference. Again, I like to go into the attributes and appearance and change my thickness to 300 micron and the last value of the hair profile at 0.1. The density needs to be increased to 100,000, similar to before. And if I'm to template in my head, I can see what this finally will look like against the vase. It looks okay to start, but I want it to be a little more spunky. To change this, I need to go to the guide maximum count. With a setting of 10 guides will influence any one of the hairs that are being grown right at this point. If I lower this number, then I can get much more similarity between the original curves that were drawn and the groom that is following these inputs. Now I have much zestier arcs as what was drawn before, and something a little more similar to what I was hoping to create from the Bezier curves. Turning off the grow unguided hair, I now only have curves that are following the input guides. Next, I'm going to attach a hair clump node connecting the input guide and the input skin to the hair generation node above. As usual, the clump size is too large by default, so I'm going to add a 0 after the decimal, change that. I can see some very large clumps formed that look similar to the original hair generation. The clump profile should be changed. I do not want the clumps to form tips. Now that I'm satisfied with new hair clumps, I'm going to add a guide process set length in order to shrink the overall groom. The mode should be changed to multiply. The method to scale. And now I can simply shrink down the overall groom using the scale factor slider. This looks like what I want. I can still control the curves from upstream, and the groom follows accordingly. This is the perfect control that I want for this kind of groom. Overall, the groom sometimes has a bit of a resemblance to a toothbrush. I want to grab a couple hairs in order to accentuate the forms. The hairs that I want shouldn't be random, so instead I'm going to use the Guide Find Strays, a new node for Houdini 21. The settings will have to be played with the size of this groom in order to be able to find those strays. But currently, the strays are not visible. So later down in the node tree, I'm going to add a color to those strays in order to be able to pick them up and accentuate some of the forms of the groom. Guide Find Strays by default outputs a group called strays, which I can reference in the color node. At this point, I want to merge bangs into the stream of nodes that I like to use for visualization. And now I can add that new color node after that stream. The group should be strays, and I'm going to choose a color much darker than the bright white that was the default. Visualizing that merge to see the groom and the head, I can return to the Guide Find Strays and adjust the settings. The root distance percentile is too high for the size of this groom. I need to reduce it. Next, I need to adjust the max distance multiple. And there we have it. Some of the more important hairs that define the shape of the groom are now coming out with a new color, and this helps break up the look to look less homogeneous. Now with these new bangs, I'm going to remove from the advection step the front scalp. Now hair slicks back only on the top scalp, while the front scalp has the new bang look. To finish this, I am again going to add an output node similar to the first iteration, and there we have it. A second iteration complete with a slightly new look, building up solutions from the first. Thank you for watching.